Hi, welcome to the Calculus 2 lecture series. And we are in the unit number 2 of the Calculus 2. We talk about the different integration techniques. Okay, so this is the third video for the lecture number 9. And so for these videos here, we're going to introduce two pretty useful formulas after you break down your integration into rational functions. All right. So in here, let's go ahead start our lecture notes here. Okay. So like I talk about in here, for the previous two videos, we'll talk about how to break into the partial fractions and then how to solve the constants, right? So afterward, so in here we say afterward in here we are going to introduce these are the two very useful formula, and which one which is like after you break into a partial fraction, if they are in this format, frequently you will run into this type of the questions here. So first one is 1 over x squared plus a squared dx. Okay, and the second formula we're going to introduce is 1 over x squared minus a squared dx here. So if you remember, like in the previous, right? So when we did the partial fractions, then the previous lecture before the partial fraction is the lecture number 8, I think. And we talk about the trig substitutions. We have the trig substitutions, like this ways here, we say like if you have your integration, have this function square roots of a squared minus x squared, and this is a squared plus x squared, and here this is x squared minus a squared, right? So that is, we discuss what is the integration formula. This is in our lecture number what? Number 8. When we talk about how to use the trig substitutions here. But now these two formulas here is without the square roots, but it's very similar, like what we did here. Like we say, after you break out to the partial fractions, frequently you will run into this type of the functions. So what is the formula for these two here? So let me write down the formula for these two here. Okay, so for the first one here, okay, so this is x squared plus a squared, and the formula here, this will be 1 over a, and arctangent, right? So this is arctangent x over a plus c, and this one's here, for this one's here, the formulas will be 1 over 2a, and then this is a natural log x minus a, and this is x plus a here. Like I say, if you can remember, that's good, and so it will. So when you try to do the integration, it will be fast. You can just write down the formula. If it's not, you certainly can derive it. It's not difficult to derive these two formulas here. All right. So for here, the way you derived it, so for the first ones here, so you still can do like what we did for the trig substitutions here. So you can do in order to get the first formula, you can do this substitution, the x equal to the tangent theta here. Then you do the same thing, you do a dx is equal to like a square second square theta d theta, and then you also can see the x over a is equal to the tangent theta here, right? Like we did it before, like we did it in the trig substitution. Then you do a little triangles here, if you remember, right? So tangent is opposite over adjacent, so it's XA. And then here, this is X squared plus A squared. And so now now we know the secant theta, right? So the secant theta is equal to what? It's X squared plus A squared over A, right? So now, because in here doesn't have the square roots here, so I can I can square both sides. So this is the secant square theta is equal to the A squared, X squared plus A squared. Did you see? Here we come out with this one. So we say X squared plus A squared is equal to the A squared secant square theta, right? Then you can substitute back to your integration. So now your integration is X squared plus A squared dx, right? Then we can substitute back. So what is X squared plus, so remember we say everything need to be replaced, right? So X squared substitute is going to give you this one here. So this will be A squared secant square theta, right? And then, okay, so in here, also I have what? I have a dx, right? So where is dx? It's here. So I can do this one is A square and secant square theta, d theta. Wow, it turns out pretty good. See here, the A square cancel, secant square theta cancel. So this integration will just be what? 1 times what? 1 times d theta, right? And so here, hold on, I have dx, I'm sorry. So here, this is dx is a, not the A square. So dx here, this is, we cancel out 1a. So here, this one, okay, so here, the d theta here, all right. So here, this is a, and so let me cancel. Okay, so now it's better. So this is a square. So when I cancel, you will have the top a cancel out with here. So what do you have here? You have 1 over a here, right? Okay, so now you can integrate. This is 1 over a. Now what is 1d theta? Will just be what? Will just be thetas, right? So what is the theta? So I know the tangent is x over a. So what is here? So this is 1 over a arctangent, what? X over a plus c, right? So the proof for the first one is pretty easy here. So I think we all can do that pretty fast. And so it's based on this is still is the same thing as the substitutions, right? Okay, so let's take a look. The second one's here. The second one, this is x squared minus a squares, right? So this one is also pretty easy. So in here you said x squared minus a squared. And then this one's here, we know this will be the x minus a, x plus a, right? Okay, so the a squared minus b squared, and a is a perfect candidate for the partial fraction. So we have x minus a, x plus a, then you have a and the b, that's right? Okay, so after you have the a and the b, then what you do, you find the common denominator. So the common denominator will be x minus a, x plus a. So this term will be a, the x plus a, then plus b, the x minus a, right? Then just like we did before, this one, the algebra is not too bad. Okay, so this is the x terms here. Like we said, so the x terms here, here's x term. So what is the x term? We have a plus b to the x. Then we also have, we call this is a constant terms, the a's here, right? So what is that? So we have a, so we have an a, so this will be a minus b's, right? Because one is negative, right? So, all right, so this is make sure, okay? So now you compare to 1, so you know the a plus b going to be equal to what? A plus b going to be equal to what here? So a plus b don't have here, so it will be zeros, right? So the a plus b will going to be 0, and then the a minus b, right? So going to be what? We're going to be 1 over what? 1 over 8 here. So if you solve the, if you solve the system of equations, then you will get a is equal to what? 1/2 of the 1 over a, and the b will be equal to the negative 1/2 over a, all right? So now you can substitute, and then that's, so now if you do the integrations here, I don't have too much space here. So now later I can erase here. So now in here is 1 over x squared minus a squared dx. Then you can substitute here will be x minus a, right? So you'll be x minus a to the dx, then you have 2a, 1 over 2a is here, minus this is the dx, x plus a, right? So this is 2a, it's outside the parentheses here. So that's why this will give you 1 over 2a. So what is the integration of here? This will be the natural log x minus a, right? So this is minus natural log x plus a plus c. So that's how you get the formula is 1 over 2a, the natural log x minus a over x plus a plus c. All right, so that's how do we get the formulas here. Like I said, if you can remember the formula, then that's good. If you cannot, it's easy to derive, right? So it's not too hard. Okay, so now let's take a look at what is the problem here. Let's take a look at how do we do the problem. So the first ones here is evaluate the following integration. Since, okay, so for this ones here, I can do is, this is what? I can take the factor, the 2 out, right? So this will be x squared minus what? 36 dx. So I can leave the 1/2 to the front. So this is dx, x squared minus 36. Oh, yes, x squared minus 36 is matched. The match this formula, the second formula. So this 36 is equal to what? The 6 to the squares, right? So what is my a's here? A is 6, correct? Now I can directly plug into the formula. Okay, so let's just plug into the formula because we already, derived it. So this will be 1/2, right? Then times 1 over 2 times what? 2 times 6, right? Now here I have a natural log x minus 6 and x plus 6 plus c. So it's 1 over 24 natural log x minus 6 x plus 6 plus c here. All right, so like I said, for these ones here, if you remember the formula, then it will be pretty easy just to plug it into the formula. Like I also mentioned, those type of the form, x squared plus something, x squared minus something, happen frequently when you break out the partial fractions here. Okay, let's take a look at the problem part B here. And I think I need to erase, oops, here, so what happened here? Let me see, I can erase something. All right, so yeah, so I can erase some, I need some space here. Okay. Why it takes so long to erase? So, all right. Get a bigger eraser. Okay. Doesn't like to erase here. All right, so that's fine. So we can erase here. All right, okay, so for these ones here, I think we should have plenty space here. Okay, so in here, we did this very similar problem. So we know the denominator is not exactly what we have x squared plus something or x squared minus something. So do you guys still remember what we talked about in the previous lecture? So what type of the skill we need to use? We need to do what? We need to do complete the squares, right? Okay, so I need to do the complete the square methods here. So let's take a look. Okay, so the x squared plus 2x plus 4. So if I complete the square, so this be x2x plus 2x, the half of it, then square is plus 1, right? So this is my the complete squares here, and then this is plus 1. So what I need to do is here, I need to plus 3, right? Okay, let me erase a little more to see. I can erase, yeah, I can erase a little more here. Okay, so now this one's here will give me, so this is the complete square. What is the square of this one? This is x plus 1 to the square plus 3, right? So it's very similar like the formula we have, the x squared plus the a squared. So a squared is here. So that means it's this terms, right? So it's this term, so the a squared. So what is my a's here? So the a is the square root of what? Square root of the 3's, right? Because I can change this one to the x plus 1 square plus the square root of the 3 to the squares, right? So now this one, this integration, I can change to like this, x plus 1 square plus the square root of the 3 square dx. I almost be able to use that formula, so I need to do a what? A u sub. So that's like the same way we did before. U is equal to the x plus 1, then the du is equal to the dx. And then this one simplify to the u square plus the square root of the 3 square du, right? So now this is the perfect match this formula. So now what is the integrations here? So the integrations here, it will be, right? So the integration will be 1 over, right? 1 over a. So what is 1 over a? Is the square root of the 3. Then I have an arctangent. What here? U over square root of the 3 plus c. Because my initial function is x, so I need to replace back everything to the x here. So I have an arctangent u. So what is the u? So it's x plus 1 square root of the 3 plus c here. Okay, so this will show you, you know, if you remember the formula, then the integration become quite easy. Okay, so now the last one, this one is kind of combined what we talk about in this video and what we talk about the previous video. Okay, so let's take a look here. All right, so this is kind of good review questions here. All right, so in here, we say this is 1x, 1 minus x plus 2x squared minus x cubed. So the highest power is 3. Then here, this is x squared to the square is 4, and then the x to the 1. So the highest powers here is what? It's 5, right? So 3 is less than 5. So I know I don't need to do what? I don't need to do the, the long division. So it's fine here. Okay, so now we're going to break it. Okay, remember when we break it, these ones here, we'll be able to break it, right? So this is one, okay, don't need to be that big. Okay, so the first terms here, so I have, all right, so I have x here, right? So I have one, oops. Okay, so I have a 1 over x, right? Then plus here. Okay, here be careful, right? So I have x plus 1, and but I have to the square term. So I need to break it. So I will have the x squared plus 1. And so this plus x squared plus 1 to the what? To the square term, dx, right? And now I need to put my constant here. So this one is x, so my constants will be what? So this one, my constants will be a. All right, and this one's here, this is x squared, right? So this is x squared, so I need to drop 1 degree. So what is this constant? This constant will be what? Bx plus what? Plus c. And now this one, because these two are the repeat, is just the power increase. So what do we have? What do we put the constants here? Still, we are dropping 1 degree. So this will be the dx plus e, right? So basically, you see, whoa, this is like 5 variables and 5 equations, right? So now we do the same thing. So we say, okay, we find a common denominator here. So the common denominator will be x squared plus 1, then the x squared plus 1 to the square. Okay, so now the x term is missing what? The x term is missing x squared. I shouldn't do like this because my denominator here is x squared plus 1 to the square, right? Because that's what was here. So a terms x squared plus 1 to the square. So that what is my a constants here. And then plus bx plus c. So this is x squared plus 1. So my bx plus c, so this will be bx plus c, then times what? Times x squared plus 1. All right. Then my last terms here, this is dx plus e, right? dx plus e. Then what is the term I need to times? I need to times x. So remember, then the remaining will just be very, very tedious, like the algebras, right? So let's try to use this opportunity, try to refresh one more time. So this is a, then this is x fourths plus 2x squared plus 1, then plus, all right, so this is a plus the bx cubed plus bx plus cx squared plus c, then plus dx squared plus ex, right? So we just need to be very, very careful to not make any mistakes here. All right, so now let's take a look at the first, let's try to highlight the first things here. Okay, so x to the fourth, I only have what? X to the, okay, so let's take a look at the x to the fourth. So do we have any x to the fourth here? Oh, here, see here, I made a mistake here, So here I need to, that's why we need to be very careful here. This one, the common denominator is times x. All right, so here I will have x to the fourth, bx squared, and cx to the cube. cx to the cube and cx. All right, so hope that we do not make any other mistake. All right, so the here, now, first I've combined the x4s. So let's try to, this item is x4s, this item is x4s. So my first equation, because I have a 5 variable, I really need 5 equations, right? So this one is equal to 0 because I don't have x4s, right? Because I don't have x4s in here, right? Okay, so now let's take a look at the next ones here. So the next ones here is x to the cube here. All right, so let's see where I have x to the cube. Oh, I only have what? I only have one item, the x to the cube. That's good. So x to the cube is -1. Ah, that's not bad. So c is equal to the -1. All right, so that one turns out good. Okay, so now let's take a look at x to the square. Okay, so x to the square. Oh, this term is x to the square. And this term is x to the square, and then this term is x to the square. So when you try to do this type of the problem, I would recommend you, maybe if you have the color pen like mine, will be easy. So the constants will be 2a plus b plus d is equal to what? X squared, the terms is 2, is equal to 2. Great. Okay, so now the next thing here, let's see here. Okay, so let's see the x terms here. Where I have x term, oh, I have x terms here. I have x terms here. Good. So c plus e. So x term -1 is equal to the -1. Okay, so the last ones here is a constant. Oh, I only have what? I only have one constant term is here. Oh, that's not bad. So I have a is equal to what? Equal to 1, right? So see here, I have 5 equations with 5 variables. So I can solve it. Okay, so I believe we all know how to solve it. So I'm not going to waste time here. So I got a equal to 1, b equal to -1, c equal to -1, and the d is equal to 1. Hey, and the e is equal to 0. Okay, not bad, not bad. All right, so here. All right, so now let's try to put back. Okay, so here, this will be a. So this is a equal to 1. So it's a dx of x. This one not bad. Okay, so then the next term is a bx plus c. Bx plus c, b and c both is negative. Okay, so I can put a negative sign here. So this is x squared plus 1. So bx plus c. So this will be x plus 1. Right? Okay, good. And x plus 1 here, dx here. Okay, now I will have here the last term is dx plus e, and to the x to the square. Okay, so e is 0, so x here, so this is x and x squared plus 1 to the square dx here. Okay, so now let's try to see how do we do the integration. This is really test your integration knowledge here. So this is a dx, this is x. This one's here. I know if I have x squared plus 1 by itself, I can integrate. So I'm going to break this one down to the x squared plus 1 to the x dx, then minus the x1 to the x squared plus 1 dx here. Okay, so I just want to highlight here, I'm breaking this term to these two because those things I know how to do the integrations, right? Then plus here, this is x squared plus 1 to the square dx here. Okay, so now let's take a look at the one I know how to do. Okay, so this is easy. So what is the integration? 1 over x is a natural log x. Okay, now this one, okay, so for this one, x over x squared plus 1. How do I do that? Then you say, oh, okay, maybe I need to use u sub here. So let's see here, the second terms here. So I will have u sub, right? So I will say u is equal to the x squared plus 1, right? So the du is equal to the 2x dx. So now I have du over 2 is equal to the x dx. Did you see here? I have that, right? So the whole first, this integration will change to, you put a 1/2 here, then what is here is u what? du. That's pretty good. So what is this one here? It's a 1 over, then it's a natural log u plus c. Now I know what is natural logs, right? So this one's here, I know what is the use, right? So I can put it back. So this is 1/2 the natural log x squared plus 1 plus c. Very good. So this one is 1/2. This is the natural log x squared plus 1. Okay, so far so good. You see the color coding, so you will not get confused. And then this one, the third one's here. Oh, this is the formula, right? We just talked about this is the formula. So I know, okay, I can directly plug into my formula. It's the arctangent one, right? So that's the arctangent one. So we can do the arctangent. So this one will be, so what is your a? Here is 1. So this is minus. So this is what? Arctangent x. Correct? So it's 1 minus arctangent x. Okay, now we have this term. All right, so this term, well, for these terms here, I also need to do the integration. So this is x, and I have the x squared plus 1. So I know, okay, I think I can do what? A u sub here, right? So for this u sub, I will put a u is equal to the x squared plus 1. So the same, so this is du 2x dx. Then your du over 2 is x dx. So this one's here will be 1/2. Okay, so what is the bottoms here? Bottom will be u squares, right? Then the du. Okay, so now you integrate here. Everybody should know. So this will be 1 over u to the negative 1 plus c. So this is 1 over u plus c. So what is the u? X squared plus 1. You substitute back. So I'm color coding here. So this one will be 1 over 2. Then you substitute u back, x squared plus 1. Right? And then finally is a plus k. Okay? So that will be my final answers here. So this problem is a very tedious problem, but it's pretty good problem because it combined, basically the lecture number 8 and number 9 and the u sub, kind of put all the integrations techniques into one problem. That's really neat, even it's a little bit tedious here. All right. Okay, so that is for this video. We covered the two kind of very helpful and useful formula when you do the partial fraction, when you break it down. And then you can just directly use the formula instead of try to derive it again. All right, that's it. So nice to talk to you, and looking forward to talk to you for our next video. We're going to talk about another integration technique. We have the u sub, we have a trig sub. Then the next one we're going to talk about the rationalized substitutions here. All right. So nice to talk to you. You have a good day. Okay, bye.